Good morning. Today is Monday, and I wanted to make another video for those of you who are learning at home. Now, if you were here on Thursday or Friday of last week, you've actually seen some of this stuff. But I'm a couple days behind, but this should catch everybody up. So if you were gone on Thursday, Friday, then this will be new stuff to you. This is what we did, and this is what you'll need to do to get caught up. We're going to continue working on this on Monday as a class, so you would, after this, be caught up with everybody else. So we've been talking about genes and how a gene is just a piece of that DNA strand. And again, here's your DNA, right? And a gene is just a piece of that. And strung all together is your whole DNA strand in your chromosomes. You have 46 chromosomes. Now, one of the things that you should have written in your notes, again, going back to when we did the heredity notes, you should have written this, but you should have written that there are genotypes and phenotypes, which we talked about the other day. Genotypes are the possible combinations of alleles you can get for a gene. So, for example, if brown hair is dominant over red hair, which would be recessive, then the letter we use for our gene would be the letter B, capital B for brown hair, and a lowercase b for red hair. There's three genotypes. There could be capital, or two dominant alleles. There could be recessive, two lowercase letters, recessive alleles. And then you could have dominant, recessive. Those are the three combinations that a person could have for their gene. Now, there's this other word called phenotype, right? And phenotype is how that gene gets expressed, how it is shown in the person. So in this case, this person's phenotype would be brown hair, because this is what gives you brown hair, the dominant allele. This person would, of course, have red hair, the recessive trait. And this person, like we said, would have also brown hair, because the dominant overrides the recessive. It's still there. It can still be passed on to the kid, but it's hidden away. You get this. Okay? Now, these genes, these genotypes have a name, and this is a new thing. This is in your notes if you took them. Make sure you have this in your heredity notes. But the genotype for these is what we call homozygous. Okay? This word right here, HOMO, means same. It's a Latin word for same. This gene is called heterozygous. Okay? This Latin word, hetero, means different. So homozygous means that both alleles are the same, and this means that both alleles are different. So one dominant, one recessive. They're different, so it's heterozygous. If you have two of a kind, two dominants, it's homozygous. Or two recessives, it's homozygous. So we often try to specify. We like to know exactly what we're talking about. I would call this dominant homozygous, and I would call this recessive homozygous. Heterozygous, you don't need to be specific. It's just heterozygous because it's just one of each. These do have another name. Okay? Homozygous genes are also called purebred. And heterozygous genes are also called hybrid genes. So purebred is homozygous, that's purebred, and so is that. Hybrid genes are heterozygous. So that is new stuff you need to know. So if we have some genes here, I want you to think about what these would be. This gene would be what of those things? Would it be dominant homozygous, recessive homozygous, or heterozygous? It's a dominant and a recessive. It's one of each. That means they are different. That would be heterozygous. What would this be? Two recessives. They are both the same. That would be recessive homozygous. This would be dominant homozygous. This would be two lowercase. They're both the same. So recessive homozygous. This would be what? Heterozygous. Okay, so make sure you know heterozygous is different. Homozygous is the same, either recessive or dominant homozygous. All right, so that's how we do that. Now, the other new thing we're learning is something called a Punnett square. Remember how we did this? We said, okay, if mom has, we'll say dangling ears, we used an example, her dominant trait is dangling, attached ears is recessive, and dad has attached ears, the recessive trait. When they have a kid, remember that mom gives one of her alleles and dad gives one of his alleles. So if mom gives this one and dad gives this one, the child gets capital lowercase, that would be dangly ears. Here, same thing. Here, they get the recessive trait, attached ears, and here they get attached ears. Hopefully this is familiar to you. We've done this a couple times in the videos and in class. So if this is new to you, you need to go back and rewatch those. Okay? So 50 chance of getting dangly and a 50% chance of getting attached. Well, there's another way that you can do this, and this is what we're learning today. This is called a Punnett square. It's just a more organized way of doing it. So if mom is this and dad is this, you can do it this way. You make a little square here with boxes like that. You put one of the genes here, like mom's gene, and then dad's gene you just flip and put here. Doesn't matter which parent goes where, by the way. And then this is just a little grid where you go, boom, mom gives this, dad gives this, so the child gets dominant recessive, because you always put the dominant first. Okay, what would go here? That would be recessive, right? Dad gives this, mom gives this. Okay, here, mom gives that, dad gives this one, you still get dominant recessive. And if mom gives this and dad gives that, you get recessive, just like battleship, right? Lining them up. And again, you can see there would be a 50% chance of getting attached dangling ears and a 50% chance of getting attached ears. That is called a Punnett square. P-U-N-N-E-T-T. Punnett square. All right? So, for your assignment today, you're going to do this first paper to begin with. These are about SpongeBob characters. The first question here, and you'll see this on your document, says for each genotype, indicate whether it is heterozygous, you can just shorten it with HE, or homozygous, HO. So for example, this first one right here, capital. Well, those are two dominants. They're both the same. So that would be a dominant homozygous gene. Remember what we talked about. Go back and rewatch it if you need to. So I would write HO, whereas this one below it, capital D, lowercase d, they are different. One capital, one lowercase. One dominant, one recessive. That would be heterozygous. What would this one be? The big B, little b? That would be heterozygous. So again, you'd write HE, right? And then little f, they're both the same. That is recessive homozygous. So if I were to fill this out, I would say, okay, homozygous, or fill it out like this, right? Homozygous, heterozygous, heterozygous, homozygous. Okay, this next question, I'm going to get you started on a few of these. You can do the rest of these in a minute. Which of these genotypes would be considered purebred? Remember, purebred is the same as, what was it? Homozygous, we talked about earlier. So purebred, so I'm just going to say all the homozygous. Okay? And then you can answer the other question. Next one, phenotype. That's, remember, how the gene is expressed. Determine the phenotype for each genotype. Well, if yellow, this is for SpongeBob, if yellow body is dominant and blue body is recessive, what would the phenotype be for this person? Big Y, big Y. They'd have a yellow body. How about this one? Big Y, little y. The dominant overrides the recessive. You get a yellow body. That's the phenotype. And little y would give the recessive trait, which is blue. So we're going to go ahead and do that. And you can pause this video if you need to fill this in with me. So there I have yellow, yellow, blue. Let's skip the next one. We'll go down to number 3 here. Just the opposite. It tells you the phenotype. You need to give the genotype, or if there's more than one. So for Patrick, if a tall head is dominant and a short head is recessive, what would the genotype be if the phenotype was tall? Well, there's 2 possibilities. You could have dominant, so capital T, or you could have capital T, lowercase t. So I need to list both. And again, feel free to pause if you need to. Right? This is number 3. Short, there's only one option, right? The recessive trait, you have to have 2 recessive alleles, lowercase, lowercase. Okay, so then you'd go down and do the same thing down here. And finally, let's do number 4 together. It says SpongeBob SquarePants recently met Sponge Susie Roundpants at a dance. Now, it says SpongeBob is heterozygous for his square shape. Sponge Susie is round. That's the recessive trait. If we look back up here, right? It tells us in this one, it says hint. Read question 2. It tells us the square shape is dominant to round. So round would be little s, little s. Okay? Create a Punnett square, one of these over here, to show the possibilities of having children. So it says that SpongeBob is heterozygous. I like to put a little box around the important things. Sponge Susie is round, so I'm going to mark those so that I remember. Oh yeah, he's heterozygous for square. Sponge Susie is round. That's the recessive trait, so I put some boxes there. Now I'm going to write their genes here. If he is heterozygous, that means he's going to be big S, little s. This is the heterozygous for square, sorry. He's square, so big S, little s. And then she is round, so she's going to be 2 lowercase s's. That's the only way you get the recessive trait. So I'm going to set that up. He's heterozygous, so big S, and little s, little s. Pause if you need to. Now when I do the cross, if SpongeBob gives his dominant allele and she gives this allele, it would be big S, little s. Here we get little s and little s. Here we get big S and little s. And then over here we get little s, little s. There's the filled out Punnett square. So now we need to answer questions A, B, and C, and then I'm going to let you do the rest of this on your own. It says list the possible genotypes and phenotypes for their children. Well, there's 2 possibilities. Dominant capital 2 capital S's is not a possibility, is it? So I'm not going to list that one, but I will say, well, this is a possibility and this is a possibility. And you need their phenotypes, what it would look like. So 2 possibilities are capital, lowercase, which would be square for the phenotype. And little s would be also a possibility, and that would be round. Pause and write that down. Let's look at B. So now what are the chances of having a child with square shape? Well, that would be square, that would be square. Right there and right there. Big S, little s. So that's 2 out of 4, or 50%. And the chance of having a round shape is 2 out of 4, or 50%. So there's that. Okay, there's number 4, all completed for you. So your job is to go back up to the top, fill out all of these, and then there are more of these Punnett square story problems. Make sure you read them very carefully. All the information you need is there, but you may have to look really carefully to figure out what their genes are. Read everything about the question. Do the front and the back, and bring this back when you get in class. Now, there's actually 2 pages. I said this is going to catch you up, but actually, this is probably enough for one day, I think. Have you do this one, and then tomorrow I'll put up the others. We're going to make a packet out of 3 of these. So once you get the hang of this, then I'll give you 2 more. Please print that out. Go back and rewatch this video if you need to get all this stuff, and then bring it back when you come back to school. Check back tomorrow for more, and I will see you guys later.